Page 7 of Trig Equations and Identities Addendum. Number 21. Prove that cosine of 3 theta equals 4 cosine cubed theta minus 3 cosine theta by replacing 3 theta by 2 theta plus theta. Okay, so first I'm going to do their suggestion, and I'll say instead of cosine 3 theta, I'm going to write it as two angles added together, the first angle being 2 theta and the second angle being theta. Then I'm going to use the equation where I write the sum of two angles with the cosine into cosine of alpha times cosine of beta minus the sine of alpha times the sine of beta. If you write out the formula every time you use it, I guarantee you're going to end up memorizing it anyway. It'll make it a little bit faster on the exam. So our alpha is going to be 2 theta, and our beta is going to be theta. So let me rewrite everything now. Cosine of 2 theta times the cosine of theta minus the sine of 2 theta times the sine of theta. Theta. So I have 2 theta here, 2 theta here. Now I can expand cosine of 2 theta, right? I can expand cosine of 2 theta into, and I am going to choose the identity 1 minus 2 sine squared alpha for the expansion of cosine 2 theta. There's 3 options, right? But I'm going to choose the one with sine squared in it because look at the one over here. I have sine of 2 theta times sine of theta. Sine of 2 theta is going to definitely expand to 2 sine cosine because that's the only option I have, right? And I'm going to do that one first just so you can see what happens. So this one's going to be 2 sine theta cosine theta times sine of theta. Now do you see how this becomes 2 sine squared theta times cosine of theta? I would like to cancel out that sine squared cosine theta. I could do that if I substitute cosine 2 theta as 1 minus 2 sine squared theta, right? If I do that, then look, it didn't really work out how I thought it was going to work out. Let me expand it for you so you can see what happened. I have cosine of theta minus 2 sine squared theta cosine theta. I'm abbreviating sine and cosine as S and C. Minus 2 sine squared theta cosine theta. Now you can see that the reason why I'm thinking it didn't work out as well as I thought it would is because, look at that, I now have negative 2 sine squared cosine theta twice, and I wanted them to cancel out, but they did not cancel out. Let's see if something else good happens. Just go to show you, this is not like, exact science figuring out how these work, okay? So now I'm going to factor out the cosine theta, and then I'll have like 1 minus 4 sine squared theta, and that's it, right? Okay. Look at my target. I want to get 4 cosine cubed minus 3 cosine theta. What if I tried to substitute the sine squared here? Instead of sine squared, what if I put 1 minus cosine squared? Then I would get rid of the sine squareds and I would just have cosine squared. So let's try that. Equals cosine theta 1 minus 4 times 1 minus cosine squared theta. Now let's expand a little bit. 1 minus 4 plus 4 cosine squared theta. And this would be cosine theta times negative 3 plus 4 cosine squared theta. And let me reverse the order. So now I'm going to have 4 cosine cubed theta minus 3 cosine theta. Oh, I got it. That's what I wanted, right? Okay, so happy ending. Even though, my strategy that I started at the beginning, I thought it would work because I would be able to I would be able to cancel out the sine squared cosine, but in the end, it worked out anyway. Okay? So, yeah, not an exact science. B, hence solve the equation 8 cosine cubed theta minus 6 cosine theta plus 1 equals 0. Okay. All right, so do you see how this equation here kind of looks like this equation here? Okay, so let's try to make this one look the same. So we would say, okay, what if I factored out 2 out of the 8 and the 6? Then I would have 2 times 4 cosine cubed theta minus 3 cosine theta, and then I just leave the plus 1 alone. Okay? Now if I do that, look, I have the exact expression there, 4 cosine cubed theta minus 3 cosine theta. So I can substitute cosine 3 theta here. Now I have 2 cosine 3 theta plus 1 equals 0. Now I can work it like a problem that's in the core. So I would subtract 1 from both sides, and then I would have 2 cosine 3 theta equals negative 1. Divide both sides by 2, and I'll have cosine 3 theta equals negative 1/2. I shrank everything and put it up in the corner here. Now we're going to make a table, and the table is going to be similar to some of the problems we did earlier, which is we're going to have left column being theta, next column being the input to this cosine function, 3 theta, and the last one is going to be the cosine of 3 theta. Okay, so basically what we're going to do is we are going to first test the maximums, and we're going to put negative pi and pi to see what the ranges transform into. It's good to do this because then you know how far you need to go for the middle values. So for example, cosine of 3 pi or cosine of negative 3 pi. Negative 3 pi would be 1, 2, 3. So it would be negative 1, right? The cosine of 3 pi would be 1, 2, 3. It would also be negative 1. Okay? So those are the two min and maximums for the theta values. And now let's take a look at what values of 3 theta lead to a cosine of negative 1/2. That would be pretty much any value or any triangle that looks kind of like that. Okay, so this would be cosine of negative 1/2. So one of the angles, the most basic angle, would be 2/3 pi, right? That would be the value of 3 pi that we're looking at. And then this other angle looks like it would be 4/3 pi. So those would be two basic angles. And then we just like multiply those angles, or we add 2 pi to those angles to find the other angles, okay? So let's put into 3 pi, we'll put 2/3 pi and 4/3 pi as two possible angles. And let's see, 2/3 pi, these both have cosine of negative 1/2, right? Negative 1/2. And look at the theta value that corresponds to 2/3 pi. It would be 2/9 pi, right? And 4/3 pi would correspond to 4/9 pi, okay? And I'm going to shrink this. Okay. Now I'm going to try to find other values of 3 pi, which are 3 theta, which would lead to a negative 1/2 cosine value. So like what if I took 2/3 pi and I added 2 pi to it? So that would be adding 6/3 pi to it, then that would be 8/3 pi, right? That would also lead to a negative 1 cosine 3 theta. And not only that, but it's slightly less than 3 pi, right? Let's do the same thing with 4/3 pi. We're going to add 6/3 pi to that, and we're going to get 10/3 pi. So that's another possible value of 3 pi. And what about if we add 2 pi again to 8/3 pi? Then we'll get 14/3 pi. 14/3 pi. 14/3 pi, that is that is bigger than 3 pi, right? Because 3 pi would be 9/3 pi. So yeah, we don't want that one. Okay? And, well, actually, what about 10 thirds pi? 10 thirds pi is also bigger than the maximum value of 3 pi. So we're going to get rid of 10 thirds pi too. Okay, so that we're left with 8 thirds pi there. Now let's try to go down. So we're going to take 2 thirds pi and we're going to subtract 6 thirds pi from 2 thirds pi. We're going to get negative 4 thirds pi. And that's fine. And then we're going to subtract 6 thirds pi from 4 thirds pi, and we're going to get negative 2 thirds pi. And can we go even lower than that? What if we subtract 6 thirds pi from negative 2 thirds pi? That would be negative 8 thirds pi. That's still okay. Still slightly less than it's closer to 0 than negative 9 thirds pi, which is negative 3 pi. What about subtracting 6 thirds pi from negative 4 thirds pi? That would lead us to negative 10 thirds pi, which is a little bit too small, right? That would be like below the minimum value of negative 3 pi, so we don't want to go there. Now we can like figure out what the theta values would be that correspond to 8 thirds pi, negative 4 thirds pi, negative 2 thirds pi, etc. So 8 thirds pi would correspond to 8/9 pi. Negative 4 thirds pi would correspond to negative 4/9 pi. Negative 2 thirds pi would correspond to negative 2/9 pi. And negative 8 thirds pi would correspond to negative 8/9 pi. Okay, and so all of these values are going to be fine as far as solutions, right? Because all these values are between negative pi and pi. All the 3 theta values are between negative 3 pi and 3 pi. Okay, so we're fine. Let's take a look at 23. Use the basic definition of periodicity to show algebraically that the period of f of x equals sine of nx is 2 pi over n for all n greater than 0. Okay, so this is, you need to have like some formula that, I think it's easier just to memorize it, but like for example, I usually think of it as sine of bx is like my standard form, and like the b for me is equal to, or the b times x for me is equal to 2 pi. Okay, because like for example, when does the sine value complete its cycle? When bx reaches 2 pi. That's the end of the cycle, right? So I can use that to figure out what my b value is or what my x value is if I know b. So in this case, I have sine of nx, right? Nx is actually equal to bx, so it's equal to 2 pi if I want to figure out what the n value is for the period, and the period would correspond to the x here, okay? So if I want to figure out what the period is, I say solve for x, and I get 2 pi over n, so there's my period right there, 2 pi over n, okay? That's it. All right. Another way you could do it is you could say that the n value is actually equal to 2 pi over the period, or 2 pi frequency. For physics people, maybe this looks familiar. So we want period, so we can ignore this equation here, and so we say, okay, solve for big T, it would be 2 pi over n. Okay? Because the b value, or the n value, is equal to 2 pi over t, or 2 pi f. Okay? So that's another way you could do it. Number 25. Use tangent theta minus phi equals blah, blah, blah to show that arctangent 5 minus arctangent 2/3 equals pi over 4. Okay, so basically we have an angle here and an angle here subtracted from each other, but they're written in a kind of a weird way, okay? So let's try to use theta minus phi to represent these two angles. Let's say tangent of theta minus phi, which in this case is pi over 4, is equal to the tangent of the arctangent of 5, because that's theta, minus the tangent of the arctangent of 2/3, because that's tangent of phi, divided by 1 plus the tangent of the inverse tangent of 5 minus, or I'm sorry, times the tangent of the inverse tangent of 2/3. Okay, and notice that 5 and 2/3 are both positive numbers, so those should lead to angles of tangent that are in the first quadrant. And if I had angles of tangent that are in the first quadrant, when I take the tangent of those angles in the first quadrant, I'll get positive ratios back. So by doing the tangent of inverse tangent of 5 or the tangent of inverse tangent of 2/3, I just get back 5 and 2/3. Okay? And the bottom I have 1 plus 5 times 2/3. So that's equal to, the top would be 15/3 minus 2/3, which would be 13/3, and the bottom would be 1 plus 10/3. So the top would be 13/3, and the bottom would be 3/3 plus 10/3, which would be 13/3, which would be equal to 1. And I have shown that the tangent of this angle here is equal to pi over 4 because tangent of pi over 4 is 1, right? So, yeah. Maybe what I should have started out with is, let's call this ugly expression, I don't know, nu, and say, okay, what we were looking for is tangent of nu, and at the end of it, I find it's equal to 1, and I'll say, oh, look, tangent of nu is equal to the tangent of pi over 4, so it worked. Okay? Whatever. That was a weird problem. 27. Find the exact value of 4 arctangent 1/5 minus arctangent 1 over 239. Okay, just to show you what a monster problem this is, here's the whole thing, and now I am going to try to show it to you step by step, okay? Okay, first thing I'm going to do is I'm going to give some names to these terrible, terrible expressions. So do you see how it says 4 arctangent 1/5? I'm going to call that gamma. Half of that, which would be 2 arctangent 1/5, I'm going to call it beta. And 1/4 of that, which would be 1 arctangent 1/5, I'm going to call it alpha. Okay, so alpha is 1 of those, beta is 2 of those, and gamma is 4 of those. Okay, and then this angle here, arctangent of 1 over 239, I'm going to call rho. It looks kind of like a P. I have discovered through experience that the best way to get to the tangent of gamma, which is 4 of this angle, is to start with the angle itself and then build up. First go to beta, which is 2 times this angle, and then go to gamma, okay? Because by doing that, we're going to find an expression for tangent of beta, which is just a number. And then we plug that into gamma. And because if we go the other way, you're just going to get this terrible, terrible fractional expression, okay? So, all right, first step we're going to do is we're going to find the tangent of 2 alpha, which is pretty easy to do. Alpha is this here. We're going to find the tangent of 2 alpha. How do we know we're supposed to find the tangent of 2 alpha instead of just finding 2 alpha? Because we have inverse tangent here. And the only way we can get rid of this inverse tangent is if we take a tangent. So, first thing we're going to do is find tangent of 2 alpha, which is the same thing as tangent of beta. Okay, so tangent of beta equals tangent of 2 alpha. Let's find it. So the double angle formula for tangent is 2 tangent alpha divided by 1 minus tangent squared alpha. And so we know the tangent of alpha is equal to 1/5, right? Because alpha is equal to the angle which has a tangent of 1/5. So tangent of alpha is 1/5. Tangent of alpha is 1/5. We substitute in there too. So the numerator becomes 2 times 1/5, and the denominator becomes 1 minus 1/5 quantity squared. So the top becomes 2 over 5, and the bottom becomes 1 minus 1 over 25, which is the same thing as 24 divided by 25. Okay? So we could simplify that a little bit. So when you divide by a fraction, you multiply by the inverse. So we are going to invert 24 divided by 25, we're going to make it 25 divided by 24, and we're going to multiply it by 2/5. Then we're going to cancel some stuff. So the 25 cancels with 5, you get 5. The 2 cancels with 24, you get 12. So we get 5/12 for the tangent of 2 alpha, or the tangent of beta. Then we're going to find the tangent of gamma, which is 4 times alpha. It's 2 times beta. So we can repeat what we did here, and we're going to rewrite tangent of gamma as tangent of 2 beta, and then we fill in beta into the expression for the double angle tangent formula. So 2 tangent beta, 1 minus tangent squared beta. In for tangent of beta, we can put 5/12 because we know the tangent of beta is 5/12. So we put 5/12 here, we put 5/12 here, so it's 2 times 5/12 divided by 1 minus 5/12 quantity squared. So the top becomes 5/6 because the 2 cancels with the 13. The bottom becomes 1 minus 25 divided by 144 because 5 squared is 25 and 12 squared is 144. Then we do the subtraction on the bottom, 1 minus 25 divided by 144. It becomes 119 divided by 144 because 144 divided by 144 minus 25 divided by 144 is 119 divided by 144. Then we're going to invert and multiply, so the 144 becomes the numerator, 119 stays on the denominator. We can cancel out the 6 with the 144. 6 times 24 is 144, so we cancel that out, and we're left with 24 here. Then we're going to multiply the top. 5 times 24 is 120. The bottom is just 119 because the 6 canceled out. So the tangent of gamma, or the tangent of 2 beta, is 120 divided by 119. Now, we have a tangent expression for 4 arctan 1/5, and we know that if we use the difference in angles formula, the tangent version, we would be able to plug that in. So let's do that. So we're going to have tangent of gamma minus rho. Gamma minus rho. That would be equal to, using the identity for difference, the tangent of a difference in angles, we'd have tangent gamma minus tangent rho, 1 over 1 plus tangent gamma tangent rho. So all we're going to do is substitute in 120 divided by 119 for gamma, and we're going to substitute in 1 over 239 for the tangent of arctangent of 1 over 239. Tangent of arctangent of 239, 1 over 239 is 1 over 239. So we plug those in here, 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 and here, and then we do a massive common denominator. The common denominator for the top would be 119 times 239. This one would become 120 times 239. This one would become 1 times 119. So it would be 239 times 120 minus 119 divided by this terrible denominator. And this one here, the common denominator is going to be 119 divided by 239. We multiply the 1 times 119, 239 on top, 119 times 239 on the bottom. We get this ugly expression. We add it to 120 because 120 times 1 is 120. And then you can see that the denominators cancel out. 119 times 239 is the denominator on top. 119 times 239 is the denominator on the bottom. Those cancel out. We're left with just the numerators. And it turns out if you put those two numerators into the calculator, 239 times 120 minus 119, and 119 times 239 plus 120, you are going to get the exact same number. Weird, huh? 28. Actually, not that weird. These are book problems, right? So weird things happen when you do it right. So you get 28,561 for the top and the bottom. You divide those and it becomes 1. So we know that the tangent of gamma minus rho is 1. So what angle would that be? Okay, well, it would be 45 degrees, right? Because the tangent of 45 degrees is 1. So gamma minus rho equals pi over 4. Okay.